Alright people, if you saw our last video about this, the iKOOLCORE R1, then you know it's a pretty capable little VMware ESXi host. But let's say you're not interested in virtualization, you want to know how well this little box can function as a firewall. Well, in this video, we're gonna find out. Hey there Homelabbers and self-hosters, Rich here. In our last video, we took the diminutive little iKOOLCORE R1 PC for a spin as a standalone ESXi host. And as promised, it's now time to see if this little cube here can fully utilize those 2.5 gig NICs as a pfSense firewall. Let's get to it. Just in case you missed our first video, here are the specs of the iKOOLCORE R1. The iKOOLCORE R1 is available with either an Intel Celeron N5105 or an Intel Pentium Silver N6005. Both CPUs are quad-core and have a base clock of 2 GHz and a boost to 3.3 GHz. We'll be testing with the N6005. The iKOOLCORE R1 is available with either 8 or 16 GB of onboard 4233 MHz LPDDR4 RAM. Our unit has 16 gigs, which is admittedly overkill for pfSense. For storage, the iKOOLCORE R1 supports up to a 2 TB NVMe SSD. We've installed a 512 GB Samsung NVMe in ours. And lastly, the iKOOLCORE R1 has a total of 4 2.5 GB Intel i226-V base T copper network interfaces. I'm going to do a native install of pfSense onto the R1, and then we'll test to see if we can saturate the 2.5 gig NICs through a natting firewall configuration using our friend iPerf3. It's also been requested that we test to see if the iKOOLCORE R1 can handle running a virtual pfSense firewall in VMware ESXi doing the same tests, so we'll add that at the end. Let's kick off the install. I built a simple bootable USB install stick of pfSense Community Edition 2.6 available on the pfSense website using Rufus. The installation of pfSense was fast and completed in just a few minutes. But on first boot, that's when disaster struck. Dun dun dun! The first boot after installation ended in the error message, pfSense cannot continue without at least one network interface card, followed by the halt of the system. Yeah, there are 4 interfaces and I can see them right here. What the hell? So I did what any enterprising Homelabber does. I started searching for the answers. I mean, right on the homepage of the iKOOLCORE website, they claim pfSense is supported. But that's not technically the case. I've come to find out that the current community edition of pfSense, known as CE 2.6, does not have the native drivers for the Intel i226-V NICs that are used in the iKOOLCORE, so it was never going to run pfSense. Further digging found that the NIC drivers are available in pfSense Plus, but you can't just download a copy of pfSense Plus. You first have to install a copy of CE 2.6 and then upgrade to Plus, which wouldn't be a big deal if doing so didn't require internet access to the device in the first place to do the upgrade. It's just dumb. Anyway, further searching also found that the development version of pfSense CE 2.7 apparently does have the drivers, so let's try again. Downloading and installing the development version of CE 2.7 was done the same way as the CE 2.6 version. I downloaded the ISO, used Rufus to write it to a USB stick, and installed it on the iKOOLCORE R1. All went smoothly. This time, after reboot, everything was as expected, and I was able to assign a NIC for WAN and LAN duties and get to testing. Before I go into iPerf3 testing, I want to talk through this mess just a little bit. Functionally, I see really no visible difference between version 2.6 and version 2.7. The installation experience is the same, and the web GUI is also the same. There are big differences in the underlying OS, however. CE 2.6 runs on FreeBSD 12.3, and CE 2.7 runs on FreeBSD 14, which is a huge difference, not to mention the native drivers for the Intel i226-V NICs. Anyway, the problem I have here is this, which I think needs to be said out loud. The iKOOLCORE R1 supports pfSense, but not the current production stable community version. So someone who comes across the iKOOLCORE website and sees pfSense is supported, buys the unit for that and attempts to get it running is gonna have a bad time, and I think iKOOLCORE should clarify that on their website. It's also important to point out that CE 2.7 is rumored to be released anytime, so it could be available right now depending on when you watch this video. Netcake doesn't have an official release date for CE 2.7 on their website, so maybe? Anyway, enough talk, let's get to testing, shall we? Alright, for any of you who have seen our previous videos testing throughput using iPerf3, this is gonna look familiar. On the left side of the screen is a Linux VM on the WAN side of the iKOOLCORE pfSense firewall that will be our iPerf3 server. On the right side is another Linux VM on the LAN side of the iKOOLCORE firewall that will be our iPerf3 client. On the bottom is an SSH session to the iKOOLCORE pfSense firewall running top so that we can see in real time the performance of the host as it handles slinging packets. Let's get this party started. On the server side, we'll type in iPerf3-S and hit enter to start the iPerf3 server. And on the client side, we'll type in iPerf3-C, then the IP address of the iPerf server on the left, and hit enter to kick this off. A default run of iPerf 3 without any additional options runs as a single stream for 10 seconds. Our first run results are promising, with a single stream pushing an average of 1.51 gigabits a second through the firewall, which is not bad. Let's test again with multiple parallel streams to see if we can reach peak throughput. For our next run, we'll add 10 parallel streams to the test. We'll type in iPerf3-C and the IP address of the iPerf 3 server, and then add a --P for parallel and the number 10 for 10 concurrent streams. Let's see what we get this time. And go. Much better results here. The average throughput was right where we'd want it to be at 2.26 gigabits a second. That's exactly what we want to see. Taking into account TCP overhead, we're effectively saturating the 2.5 gigabit link using 10 parallel streams. The iKOOLCORE 1 is clearly capable of fully utilizing the 2.5 gig ports on it, and that's great news. One final test, let's run the same 10 parallel streams again, this time for 5 minutes, to get a solid average on the throughput. We'll use the same command as last time, but add a lowercase -t and 300 for 300 seconds or 5 minutes. I'll speed this up for brevity. And action. While this is running, I do want to point out top running in the window below, specifically the CPU utilization. pfSense is spreading all of those parallel streams out across 3 of the 4 cores pretty well. You'll notice that CPU 1 doesn't have any load on it, but the other 3 cores do. pfSense reserves a core for OS operations so it can function and not hang during heavy workloads. And in the end, we see the 5-minute average comes out to 2.24 gigabits a second, right where we'd expect. Good job, little cube, good job. So natively, the iKOOLCORE R1 has what it takes to fully utilize the NICs on board, which is good to know if you're looking to run a miniature firewall and are concerned about its performance. As promised though, what about running pfSense as a VM running on ESXi inside the iKOOLCORE R1? Well, let's test that too. Before we hit the tests, let's take a look at the pfSense VM as configured, running on ESXi inside the iKOOLCORE R1. Here's our VM happily running on ESXi. I've given this pfSense VM 3 vCPUs, 8 gigs of RAM, and a modest 30 gigabytes of storage. It's important to note that this is the only VM currently running on ESXi inside the iKOOLCORE R1, so there's no concern about resource contention or other VMs interfering with our testing. Same setup as last time, server on the left, client on the right, and go. Oof. In the default 10-second single stream test, we barely crested 1 gigabit per second. That's not great. Let's run the test again with 10 parallel streams to see if we can squeeze out better throughput numbers. Yeah, nope, it doesn't look like adding additional parallel streams really did much of anything for us, with the test coming in only slightly higher at 1.08 gigabits a second. Those are pretty dismal numbers in contrast to the native install of pfSense. Since I don't think it's really going to make much of a difference at all here, let's run the 5-minute average test with 20 parallel streams just to see what happens. And go. Interestingly enough, running 20 parallel streams did show us slightly better throughput with a sustained average throughput of 1.17 gigabits a second. Not great, but hey, that's not a surprise. Obviously, running pfSense as a VM is less than ideal performance-wise compared to the native install of pfSense on the iKOOLCORE R1. And if throughput performance is what's most important to you, then go native all the way. I can still see a use case for running pfSense as a VM on ESXi in the iKOOLCORE 1. Say, for example, you're looking to run the R1 as a portable self-hosted stack, and firewall protection is part of that, and you don't need 2.5 gig throughput. But for those looking for raw power, you're gonna wanna go native, assuming you install a copy of CE 2.7, you know, because of drivers. All in all, it did a great job as a little pfSense firewall, and knowing the caveats means you don't need to waste time figuring it all out like I did. Eventually, CE 2.7 will be out of development and will be the production stable version, and then this won't be an issue anyway. In the meantime, I do recommend that iKOOLCORE add some clarification to their website around pfSense. And that, friends, will do it for this video. If you liked it, throw us a thumbs up and a sub, or if you have a beef with anything I said, please leave it in the comments below. Special thank you to our YouTube subscribers for supporting what we do here on the channel. You guys are awesome. If you'd like to support us, check out our YouTube memberships or buy some swag. It all helps us keep making videos. And now you finished watching this video, how about checking out this great playlist over here of other great Homelab and self-hosting videos we've done in the past. If you're looking to get into virtualization, Homelab, or self-hosting, we can help.